My name is Sam DiOttavio. I'm in the electronics and computer engineering technology major. What I have here is a alcohol sensor circuit, and this basically will pick up your alcohol content in the sensor right here, and basically depending on how much alcohol content it picks up in milligrams per liter, there's a little resistor coil inside the sensor, and the voltage or the more content it pick up, the lower it'll make the resistance go inside this coil, which will cause the voltage on the output of the circuit here to go up. And I created a spreadsheet here with numerous calculations for each alcohol level and the voltage, the calculated voltage that it's expected to put out at each level alcohol concentration.
Okay.
What I did for my class is I created a light to simulate a car door locking or car shutting off, you know, whatever you want to picture.
To prevent someone from starting the car.
To prevent someone from driving if they're over the legal limit. Now, as you might know, the legal limit for Pennsylvania for driving, if you're over 21, is a 0.08 blood alcohol content, which in this case would output 948 millivolts if you are at that level. And what I did was I converted that voltage using a 10-bit A to D resolution. I converted it to a hexadecimal value in order to write this C program to tell my relay to turn on my light if the voltage is greater than 948 millivolts, which would indicate that you are above the 0.08 BAC and you're not able to legally get behind the wheel of a car and operate it.
Right. Okay, so this program actually runs on the microprocessor, microcontroller here.
This is an HC12 board. This program is running on this CMB chip right here. And basically I took this is my A to D data register. This purple wire here, I'm feeding the output of my circuit into the microcontroller.
Right, and this is you showed me the conditioning circuit on your spreadsheet, right?
Right, yep.
What amplifies the signal and conditions it so that A to D converter can process the information. Okay, cool.
So what I did was I took this A to D register, that's where the voltage is going to go from coming out of the circuit, and I basically, because I said C1 is the value for this voltage at the legal limit, so I said if this register is greater than C1, I'm going to turn this port T on right here, and my port T is this red wire here, so coming out of here, I turn the port on, it's going to send out 5 volts from this red wire to this positive contact on this relay. When the relay turns on, this red light will turn on, and this will it'll turn the light on. I have a cable going into the wall, 120 volts AC.
And that's why we have tape here, so you don't accidentally touch those terminals.
Yeah, because I did accidentally touch the terminal this morning, and it didn't feel too good.
No. Woke you up though, I bet.
Yeah. So I am simulating a drunk person with rubbing alcohol, which I put on this towel here. So I hold this up to the sensor. I might need to put more on. And you can see the voltage going up. Once it gets to 940, this light's going to turn on. Like that. And as you can see, my port went on, putting out 5 volts. Because I have my meter hooked up to that port.
Right, turning on the relay.
Right, and then, so this is indicating that this person is too intoxicated to get behind the wheel of a car right now. And you can see once it gets below 940 millivolts, the light will shut off again.
Wow, that's a pretty fast sensor.
Saying that you're okay to drive now.
Okay, cool. All right. So. Now, is this part of your senior project?
This is actually my midterm project for control theory.
Okay, all right.
So this is that's what everyone in here is working on. Has their control theory project for Mr. Neuhard's class. So he wanted me to use a relay and a light to implement a control system. So I was able to get that done just in time for the open house.
Awesome. So you can package this up, and maybe a fraternity might be wanting to rent this from you then, huh?
Maybe.
Money maker. Okay. Awesome. Thanks, Sam.
Yep.